Mr. Alex Santander. And before he's presenting, I would like to give you a brief intro about Alex. Alexander is civil electrical engineer and a master in electrical engineering sciences with a specialization in power electronics from the Federico Santa Maria Technical University, Valparaiso, Chile. He also has a diploma in business management from the University of Chile. He's going to deliver with us energy transition in Chile, the key role of renewables, storage, and green hydrogen. Hi, Alex.
Thank you, Jessica. Can you hear me?
Yes, I can hear you well.
Perfect.
Could you please share your PPT and start of your presentation? Thank you. You can speak in Spanish. Our interpreter will do the translation service. No worries.
Perfect. Muchas gracias. Ahí están. Can you see my screen?
Yes, perfect.
Okay. Bueno, primero que todo.
Well, first of all, thank you very much for your invitation. And good morning to everyone from here, from Chile, and good afternoon or good night to some of you that are seeing us from other parts of the world. In my case, I'm going to start with an introduction.
Hi, Alex. I'm sorry.
¿Me escuchan?
Alex, I'm sorry. We had some
Can you hear me?
Translation technical problems. Hi, Jos, I think you should switch the translation channel.
I am in English. I am in English.
Okay. So, Alex, could you please help to turn off all your translation tools? Turn off, close. Thank you.
Okay. Can you hear me well now?
Actually, I cannot hear you well. Please close all your translation tools. Close the translation windows.
I have off my translation.
Yeah, off the translation window.
Yeah.
Off the translation window. Thank you.
That's it. Yeah. Can you hear me well now?
I can hear you well. Thank you.
Yeah, okay.
Gracias.
Thank you so much.
Gracias.
No hay problema. Muchas gracias a ti. Okay.
Thank you very much. Thank you. This is an introduction that is going to show you what energy transition is in Chile, understanding that energy transition is common to many other countries, especially here in Latin America. In my case, the presentation is called Energy Transition in Chile and the key role of renewables, storage, and green hydrogen, which is very important as a challenge in terms of a challenge as a country and our position in the world. As I said, my name is Alex Santander, and I'm the head of energy planning and new technologies in the Ministry of Energy in Chile. So my apologies, because I'm going to go very fast in this presentation. I don't have much time. And also because there are a lot of things that I need to see. There are a lot of things that I want to cover. I'm going to give you some data that, I'm going to fly through it. So if you guys have any questions later in the future, please, you are welcome to contact me. So firstly, I would like to start with the energy context, with the motivation, with why we're doing what we're doing. All of us know that we have a significant challenge in terms of climate change. Nowadays, we have significant emissions in the world, also in Chile, coming mostly from energy sources in our countries, in our nations. As you can see here in this graph, nearly 80% of the CO2 emissions in Chile come from energy sources, from energy uses. There's electricity, transport, and you can see that we got buildings, industry, fugitive emissions, amongst others. So that's a big problem. It's a big problem. Energy generation is a big problem, but as a big problem, we're turning it into a big opportunity and a big solution so that we can address climate change and air contamination that affects many of our countries. And this will be a significant, it is a significant challenge, but also will be a significant solution. But we have to be quick because we are in debt with society. So it is important for us to tackle this, not only in terms of climate change as such, because of all the Paris Agreement, etc., but also in terms of the quality of the air that we breathe. In Chile, a large part of the country between the north and the south uses wood. Firewood is an important energy source to heat up their houses, to cook, to dry their clothes, and to light up their houses. So that type of challenge it means that we have a type of firewood that is very polluting. What we need to do is to electrify that consumption, of course, supported or based on the use of energy sources that can replace the firewood. That is our motivation. So what we always like to show is here you can see the north of our country is on the left, and then the south is our renewable energy potentially. We are a country with a lot of potential for renewable energy, especially solar radiation in the north of the country, the best solar radiation index in the world, and that is fantastic as a country. But in yellow and red, you can also see wind power, geothermal power, and sort of photovoltaic power. In green, as you can see, is the wind energy, and we have potential for wind energy throughout the country. And one of the things that we like to say is that current installed capacity is more than 80% the installed capacity that we have in our national grid, which is nearly 30 gigawatts of installed power. So having said that, and considering that motivation, we asked ourselves, how can we be carbon neutral by the year 2050? You can see here, there's a significant number of emissions. In the top, you have a reference scenario in which we do nothing, and it shows that our CO2 emissions would go down and then would continue to increase. But then the curve at the bottom shows a carbon neutrality scenario, which is our target. So what is important to achieve that challenge? Energy efficiency. That means using less energy for the same purpose through improvements in the supply of energy for use, to train society to make sure that we use energy in a better manner. And that takes more or less 35% of the challenge and of the opportunity that we have. Then we also have to consider renewable energies. This, in our case, is 22%. This is the driver that moves us to move forward, because renewable energies allows us to power things that right now are being powered by fossil fuels. So here we have a significant challenge and a significant opportunity. We also have electromobility. Green hydrogen, which is the result, or is a key component to reach some end users that cannot be electrified so easily. Green hydrogen can be used as a fuel cell, and this is the key link that we need to close to make sure that we can close the loop. And then, of course, we have to consider the additional forest carbon capture. And we have to continue promoting the use of green areas so that we can continue to capture some of the emissions. So we need to work on significant grid mitigation actions towards a net zero scenario of carbon neutrality. And that would be based on our commitment as a country and as the world, which is something that a lot of people talk about. So what are we doing in Chile? We are removing coal. This is our priority. We need to remove coal from our energy matrix. So first we need to clean it so that we can bring renewable energies to the end users. Chile, 40% of its power generation right now comes from fossil fuels, coal mostly. So we have a significant presence of coal in our energy matrix that we need to reduce. That's why we develop a plan for coal reduction. And by the year 2025, we will have reduced 65% of the installed capacity of coal. And that will drive us towards a future that is more renewable and a more sustainable development as a country. This is the picture of the 6 areas where we need to remove power generation using coal. And we also need to think how we're going to reconvert those cities so that they can have a new sustainable development model. So I show you this slide so you can see that when you remove coal and clean the matrix, there are 4 things that we need to implement to clean our country. Green hydrogen, so that we can optimize freight transport. They use in machine drive in mining and heavy industry. Also, we want to electrify heavy machinery, rotating machinery that is used for mining and electromobility, and also HVAC, air conditioning, heating, etc. All of that together with energy efficiency will take us to a situation of carbon neutrality, which is the target. This is what we want. So this renewable electrical system is something that will allow us to have a clean energy future. I want to say that many of the slides, you have a QR code that will take you to some documents of our Ministry of Energy in case you want to have further information. So having said that, this is the power generation condition that we had in my country from left to right. You can see a gray dotted line, which is the difference between what is projected to what we did. We show you this slide so we can see that over the next 8 years until the year 2030, we have a significant challenge to undertake. Here we have the different colors based on the different type of renewable energy power generation model or source that is used. So you have red for storage, orange for concentrated solar power. You can see right now we have significant presence of coal, as I was saying earlier, because our country had heavy mining. Our country had a lot of hydro in the beginning. It was very blue, but it reached a level that got stagnated, and that's when we started developing through coal. So, and that is now what we need to reduce. I think hydro is a color that is going to stay in time. But as I was saying, since we were developing as a country, we need a different source of energy, and that's we had coal. But now black will reduce as we phase out coal and we increase the presence of other energy sources, solar, wind energy, etc. In the year 2013 is when we started to unfold renewable energies in our country. And as that happened, as renewable energy grew, we were able to start shutting down some combined cycle, some fossil fuel power plants in my country because they are contributing to climate change. So please keep this image in your heads of what I'm showing you, because now it's going to change a little bit. Here, I am showing you the level of solar photovoltaic penetration by the year 2030. And you can see that right now we have a little bit more than 10% of the energy that is generated in Chile coming from photovoltaic solar energy. And by the year 2030, in just 10 years, that will increase to nearly 30%. It will be actually 27%. And you can also see that concentrated solar is also going to increase from pretty much 0% to some about 15%. So between the two of them, we're going to have about 40% of power generated in my country that's going to come from solar sources. And that's a significant challenge because we need to roll out significant infrastructures. We need to modernize the country and we need to evolve. And now I'm going to show you a graph of what's coming for us. What we did last year and what's coming for us this year. We're putting into the grid, we're commissioning a lot of renewable power plants. We have over 6 gigawatts, as Jessica mentioned, that are going to be commissioned between last year and this year. In addition to that, we have also non-conventional sources, and that confirms that the long-term contracts that we have established are a driver, super important for investing in renewable energies. That is our commitment. Between the year 2023 and 2027, renewable energy insertion will continue. We will have some 15 gigawatts being poured into the system. And we have to consider that our hydrology plants are going through a very dry period as a result of climate change, and also that the coal-fired power plants are being phased out because of a plan that was established between the utilities and the Chilean government. So, as part of this transition, natural gas will assume a more significant role. Also, we have to consider that at the end of this decade, we will need a significant energy, an increase in our capacity to store energy so that we can further promote the use of renewable energies. So in Chile, we need some 2 gigawatts of storage so that we can continue integrating renewable energies into the grid. And that's about 50% of the total power output. If we add, solar energy and wind power, we will exceed that 50% by the year 2030. So now let's take a look at the future of energy. I just wanted to say that recently we just completed our project, planning project for establishing the policy that we'll have for the long-term development of the energy sector in Chile. And this is something that you can see if you want in this using that QR section. So you can contact me, you can use the QR. If you have any feedback, I'll be happy to listen to you so that we can continue to improve our tools. And this document led us to develop 3 future scenarios in the country so that we can assess them and develop public policies that foster digitalization, new energy changes towards a more renewable future, a future that is more solar and based on the use of wind power. To develop these scenarios, we need to work jointly with the population, with the citizens, with society, with the idea of projecting our energy demand as a country, the energy supply that can satisfy that demand, and also the energy infrastructures that we need to connect energy and demand. Lastly, since the energy sector is the key to all this plan, what we need to make sure is that our power grid is strong enough. So considering these scenarios, achieving carbon neutrality, which is something that we want to do, and a scenario of accelerated transition, I think we will be able to see some results that are going to be very promising. We have also increased the taxes on carbon, on coal, for the future years. That tax can go between $10 to $70 per ton of CO2, with the idea of promoting the use of clean energies. The idea is to penalize dirty energy so we can somehow encourage the use and implementation and installation of clean energy. Obviously, in the graph you can see here on the right-hand side, the graph kind of decreases in terms of coal use. We're starting with 5,300 megawatts, more or less. And by the year 2030, probably all coal will have to be phased out if this scenario of accelerated transition takes place. So that's what we're working on. And this is very important because in Chile, electrification level of final energy consumption is 24% provided through electricity. So what this carbon neutrality plan establishes is that 24%, which is a fourth of a final energy use, should turn into about half or 3/4 of the final energy consumption. So we need to be ready to ensure that we can triple our power generation from clean sources in the short term. And we will do that by phasing out coal and promoting the use of clean energy, solar, wind, and other sources of renewables. We know that electrification is going to be developed for different purposes. And it's also good to say that we do not only use a system that is reliable, but it's also resilient to climate change and that empowers enhanced services amongst the consumers. Having said that, our electrical system nowadays operates kind of like this. Coal and photovoltaic energy, you can see that on a per year basis, some 35% more or less is generated by coal, and the renewable energies varies. So photovoltaic and wind energy have increased in type between 20 to 20% this last year. And we hope that that percentage continues to increase next year, because next year we're going to commission a large number of projects. As we were saying, 6 gigawatts that are going to be available to supply and pour power onto the grid coming from renewable sources. Here, you can have the different locations of our power plants in the country. Here you have our projects from north to south. And what is interesting is to see the yellow color, because the yellow color is solar photovoltaic. You can see it's very concentrated in the north. So in Tarapacá, Antofagasta, Atacama. But in the future, we will hope to roll out other forms of energies. In this slide, on the left-hand side, you can see the yearly consumption of our country in each one of the regions. And on the right-hand side, you can see the breakdown of power distribution, or power generation rather, for each one of those regions. You can see here the different transmission lines, solar, concentrated solar power, photovoltaic. You can see, for example, in Tarapacá and Antofagasta, so photovoltaic solar energy is increasing significantly between now and 2030. I mean, this decade. If we looked farther into the future, that percentage would increase even more. In this graph, just keep the message that our energy demand between now and the year 2050 is expected to increase significantly, and probably even doubling or even being fourfold what it is right now in less than 30 years. So that means it's a significant challenge that needs to be covered by power generation sources, and this is the installed capacity that will cover that increased demand. You can see the significant role of solar energy in the future. So here, well, we're basically talking about a big opportunity for this sector. And then, of course, not everything is large-scale projects. We're also encouraging, as with the idea of satisfying our power demand, to encourage distributed projects, distributed energy projects, that in the future might reach maybe 2 gigawatts in the future as distributed power generation. So we're calling all investors in this type of projects to look at Chile as a country with incredible opportunities, because we think distributed energy is going to be very interesting in the future. And we want to develop these not only large-scale projects, but also small-scale projects. So these projections have been developed based on a number of methodologies that kind of forecast what is the performance of society and the behavior of society. And here, something that is important to mention is that 0.3% of our capacity is solar energy distributed. And by the year 2030, that 0.3% could become 6 or 8%. And in the year 2050, that percentage would remain. We're talking about a significant number of megawatts, because as you can see, the utility scale is changing, it's increasing significantly. And these are the last few messages before I stop. These are representative of each one of the months. This is our energy demand. And here you can see how generation follows the demand. You can see that the sun in the yellow color, solar energy, is increasing its leading role. And if we look at the year 2030, you can see how the sun, the yellow color, is just very dominant. And it will be the source of energy that will allow us to satisfy or to meet the increase in demand, not only with the existing demand that we have now, but also, for example, new uses such as electromobility or the use of green hydrogen, for example. This is my last message. We're not only talking about infrastructure, we're not only talking about renewable energy, we're also talking about a key pillar. We're also thinking here about the future operation of our power grid. This is a challenge that we're all encountering. And in our case, we're encountering this challenge even faster than other countries, because we're not going to have a lot of the fossil fuel plants, and we're going to start to operate a system that is more unstable, with a lot of inverters connected to the grid, with no rotating equipment. And at the end of the day, rotating equipment are much more simple to operate in terms of the grid. So we're going to have a system that is a little bit more complex in terms of the stability of the grid. We need to make sure that our grid is very stable, and how we develop solutions to make sure that we provide a solid basis to ensure the stability of the grid. We will have investors, we will have a number of tools and technologies that will allow us, through investment, to develop the technologies that we need to reinforce the capability of the grid, because we know solar photovoltaic energy has its challenges, but it has incredible opportunities. If we consider the need to launch research and have digital solutions, we will be able to increase the photovoltaic capability in our grid much faster. In addition to that, there are also alliances with some energy consumers, and who really like solar energy, that could be a very interesting partnership to decrease energy generation costs and also to reduce greenhouse emissions. And of course, we have a very important natural gas park that will be very important as a transition fuel. The years of useful life of that park is what you can see here in the slide, and a large part of that park has exceeded 20 years of operation. So this will only be a solution, a transition solution, but the actual destination, the end goal will be only renewable energies. And all the other technological uses that you can see here. I'm just going to mention the photovoltaic power plants with inverters, because the inverters are very important. The inverters are kind of like a computer that can do whatever you want with the grid, and we need to make sure that we foster the development. That is a challenge for us in which we should collaborate. All our countries should collaborate to develop state-of-the-art inverters that are very stable, that ensure the stability of our grids, because in our grids, some of the stable fossil fuels in terms of the grid are being lost. There are many other technologies you can see in this slide. And lastly, we have thermoelectric power. There are a lot of people working in thermoelectric. So what we're trying to do is researching and promoting the conversion of thermoelectrical plants in other type of plants. For example, changing from coal or natural gas power plants to synchronous capacitors that can support the operation of the grid, and also to the generation with hydrogen, using the same plants, but to generate power, but using green hydrogen or synthetic fuel, so we don't release anything into the atmosphere. This is the last thing now, for sure. How are we going to electrify consumption? And since the Ministry of Energy, we have a number of programs that are supporting companies in the implementation of renewable energy. The name of that program is Ponle Energía a tu Empresa. The idea is to support small and medium enterprises to establish renewable energy, self-sustainable renewable energy solutions. We have another program that is called My Electric Taxi, Mi Taxi Eléctrico, that supports taxis so that they can change from combustion to electromobility. We also have a program that is called Change Your Heat, which is aimed at putting a lot of houses together, creating clusters of houses so they can launch themselves into massive purchase of this type of energy, and also electrify the power generation at a smaller cost. And lastly, the solar house, which is kind of like a mixture, which is to install photovoltaic in the houses with the idea of electrifying certain things, for example, the HVAC, air conditioning, etc. So that's it. This is the last slide. The challenges that we have: digitalization, storage with increased diversification, increased use of photovoltaic, the transmission and storage system expansion. We also need enhanced capabilities when it comes to the improvement of our service quality. When we're talking about the power grid, because we're going to electrify things more, we need to have a better grid. We also need to look for optimal mix between utility scales and distributed renewable projects. We also have to promote resilience and reliability within the distribution systems. This is a very interesting opportunity so that we can decrease the levels of energy poverty in some households in which people have very poor energy levels, which translates into very poor quality of life. So in, collaborating with renewable energies, we can try to improve the quality of life of a lot of people. And then finally, the role of the state, of the country, of the government as a facilitator in this process. So that's my presentation. Thank you very much. I hope I have stick to the timeline that you gave me. Thank you very much.